You know, in JavaScript, timing is pretty much everything. So how do you tell your code, hey, wait a second, don't run yet? Well, today we're going to crack the code on one of the most fundamental ways to do just that, the callback function. It might look a little intimidating at first, but trust me, the main idea is actually super simple.
I mean, think about it. As a developer, you run into this all the time, right? You need to grab some data from a server, but you can't show it on the page until it actually arrives. Or maybe you're reading a file, and you can't start processing the data until it's all loaded up. So the big question is, how do you make absolutely sure that one task happens only after another one is totally finished? This is the classic problem of timing and order in our code.
And the answer? It's the callback function. Honestly, the best way to think about it is like giving your phone number to a restaurant on a busy night. You don't just stand at the host stand waiting for your table, right? No way. You give them a way to call you back when they're ready for you. It's the exact same idea in code. You're not passing a phone number, you're passing a whole function as an argument, basically telling the main function, hey, when you're done with your thing, run this for me, would you?
Okay, so theory is great and all, but seeing it happen is what really makes it click. So let's break down a really simple example. We've got two main functions, our cast of characters, and we're going to see exactly how they play together.
First up, we have our actual callback function. Its job is incredibly simple. When it's finally called, it's just going to log a little success message to the console. That's it. Think of this as our all done notification. For now, it's just sitting there, patiently waiting for its queue to run.
And here's our main function, the star of the show, add. Now look closely at its parameters. It takes two numbers, A and B, and this is the crucial part, a third parameter that we've just named callback. So when we call the add function, we pass in our numbers, and we also pass in the entire callback function itself as that third argument. And notice, we're not running it yet. We're just handing it over, like a tool for the add function to use later. Okay, so we've met our two functions, we've seen how we call them. Now let's trace the exact sequence of events when this code actually runs. This is really where the light bulb moment happens. So the flow is absolutely critical here. First, the add function gets called. We hand it the numbers and a reference to our callback function. Second, inside add, it does its main job. It calculates the sum and logs that result. And then, and only then, as its very last step, does it finally execute the callback we gave it. See the key? We don't call the callback directly. We delegate that job to the add function, trusting it to run our little notification function only when its own work is 100% finished.
And this is what we get. Take a look at the console. The output shows up in this perfectly predictable, guaranteed order. First, we see the result from the add function, and second, we see the message from our callback. This sequence is no accident. It's exactly what we designed and controlled.
But what's the single most important piece of this puzzle? What's the trigger that makes this whole thing work? Let's zoom in on that one critical moment, because this is where the magic really happens. This quote right here just nails it. If you didn't call callback function inside add, the second message wouldn't appear. That single line of code, just callback with the parentheses, that's the trigger. That's the main function explicitly saying, okay, my job is done, now it's your turn, go. This side-by-side comparison makes it crystal clear. On the left, when that callback line is inside our add function, we get the full two-line output we expect. Perfect. But look at the right. If we just remove that one single line, poof, the success message is gone. The callback function was passed in, it was ready to go, but it was never actually told to run. This just shows you the absolute control this pattern gives you.
All right, let's boil all of this down to the most important stuff. If you're going to remember anything from this explainer, it should be what's coming up right here.
So let's lock in these essentials. 1. A callback is, at its heart, just a function that you pass into another function as an argument. Simple as that. 2, and this is the big one, it's specifically designed to be executed after the main function is totally done with its job. And 3, the whole point of all of this is to give you, the developer, precise control over the order things happen. It's how you manage tasks that don't finish instantly. Seriously, once you master this pattern, you unlock the key to handling everything from user clicks to fetching data from an API. But it also opens the door to a whole new, kind of mind-bending challenge. What happens when a callback needs its own callback? Yeah, think about that for a second. Once you start pondering that, you're well on your way to truly understanding asynchronous JavaScript.